Welcome to our deep dive into the mysteries of the Sacsaywaman complex. This video will shed light on a scientific report from 2012 that has largely gone unnoticed for the past decade. The Sacsaywaman complex, a World Heritage Site and one of the most important monuments of the Inca civilization, has been experiencing destructive processes caused by meteorological and anthropic agents. These processes have led to the formation of cracks and dislocations in the walls of the complex, threatening its structural integrity. In response to these alarming developments, the Ministry of Culture of Peru summoned a team of geophysicists and researchers from the Moscow Institute of Geophysics and Sea Research in 2012 to analyze the situation. Their mission was to reveal areas of greater humidity, cracks, ruptures or faults, and locate underground objects that could be contributing to the deterioration of the complex. In this video, I will walk you through the report, summarizing its key findings and highlighting the 5 major discoveries it reveals. In 2023, I stumbled upon a YouTube video that featured an interview with a Russian scientist who had been part of a study at Sacsaywaman in 2012. The interview was conducted by Giacomo Lungato, who runs his own channel dedicated to such intriguing topics. Intrigued by the insights shared in the interview, I decided to delve deeper. Giacomo encouraged viewers interested in the report or with questions about it to reach out to the scientist directly. So I took the initiative and sent an email to the scientist requesting a copy of the scientific report. To my delight, he was kind enough to share it with me. The report was originally in Spanish, but I have managed to translate it into English with a high degree of accuracy. This has allowed me to gain comprehensive understanding of the findings and their implications. In the following sections of the video, we will delve into the details of this report, exploring its key findings and the major discoveries it reveals about the Sacsaywaman complex. The revelations of this report are indeed groundbreaking. The findings about the Sacsaywaman complex should, in my opinion, be making headlines around the globe. In the following segment, I will be quoting from the translated report that was finalized and signed in Arequipa, December 19, 2012. Quote, the title of the report is Complex Study with GPR Scanning Technology of the Subsoil of the Archaeological Site of Sacsaywaman. The participants in the study were Engineer Andrei Veryanov, Engineer Alexander Drostov, Engineer Ramon Sotomayor, and MG Armando Minaya Lizarraga. Introduction. In recent years, it has been observed that the archaeological complex of Sacsaywaman suffers destructive processes by meteorological and anthropic agents, and that the National Institute of Culture of Peru, INC, was informed by personnel in charge of maintaining these ruins. These destructive processes refer to the formation of cracks with humidity in different points of the walls, causing dislocations of the main walls, in some cases leading to collapse. At the beginning of July of this year, the Ministry of Culture summoned a group of geophysicists and researchers from the Moscow Institute of Geophysics and Sea Research through its representative GEO and ASOCIADOS in Peru, and in coordination with the Regional Directorate of Culture of Cusco, in order to analyze the problems that have been occurring in the Sacsaywaman archaeological complex. Background. In recent years, it has been observed that there have been profound meteorological changes, such as increased rainfall, temperature, among others, pollution of the environment by gas emissions, affecting different regions of the world, and the archaeological zone of Sacsaywaman is not exempt from it. These changes or destructive processes can lead to catastrophic situations for one of the most important monuments of the Inca civilization, and recognized as a World Heritage Site. As a result of this problem, a comprehensive study was required to determine the causes of the slow destruction of the Sacsaywaman complex. The search for a technology that helps to accurately interpret these phenomena was essential, resorting in the first instance to conventional geology and geophysics technologies, which did not offer the clarity or the necessary details to help make important decisions to stop these destructive processes of the complex. In addition to the problem that is related to soil and water, there is also the deterioration of the blocks of the archaeological zone due to the action of the environment causing erosion of its surface, as shown in photographs. This problem is of equal importance due to the impact it causes in the architectural conservation of the blocks. In the month of June of this year, the Regional Directorate of Culture, DRC, of Cusco requested the Ministry of Culture that the archaeological complex of Sacsaywaman be declared an emergency, that a team of specialists prepare an intervention plan to safeguard the Inca heritage from the archaeological, topographical, geological, geophysical point of view, etc., that is, a multidisciplinary team. Purpose. The objective of the team of researchers from the VNIISMI Institute of Moscow was to carry out a scan of the Inca complex of Sacsaywaman to reveal areas or zones of greater humidity, cracks, ruptures or faults, locate objects underground, etc. Description of the equipment used. Data acquisition. The scanning was carried out in the month of July on the platforms of the Sacsaywaman architectural complex. Photograph number 1, with the intervention of engineer Andrei Veryanov and Alexander Drostov, Ramon Sotomayor and Igor Alexeyev, and the supervision of a representative of the DGC Cusco, archaeologist Luis Guevara and geologist Edith Quicuana Zavala. To achieve our objective, various antennas with various scanning regimes were used until obtaining the most precise information. Approximately 1.5 kilometers were carried out. Photograph number 1. Location of the scanning lines on the platforms of the Sacsaywaman architectural complex. Photograph number 2. GEO and Asociados SRL staff performing the scan. Processing and interpretation of results. The results of the scans were sent to the Institute of Analysis and Interpretation. This data analysis was performed by engineer Pavel Morozov, director of VNIISMI Institute and leading specialist of GPR technology. According to the background and the logic of the technology, it was decided to use the GPR to scan the levels of the Sacsaywaman fortress in order to know the shape of the internal structures of the subsoil at each level and thus be able to comparatively analyze the continuity. Investigation of the 4 levels of Sacsaywaman. In the research process, 4 profiles have been carried out on the 4 main levels of the complex. To have greater resolution and clarity, the profiles were made with a step of 10 centimeters. The step was specified with the help of a tape measure placed along the path. The one of the greatest interest that caught our attention is the one located below the 3rd and 4th level, which is between 60 and 70 meters in surface distance from the landslide to the west. A vast area of fractured rock was recorded in the level 4 area. The depth of the fractures detected goes up to 10 to 12 meters. Figure number 2. Radargram where the limit of the zone of fractures of the subsurface of the walls is observed. Figure number 3. Filtered radargram where the limit of the fractured zone and the reflection of radio waves from the subsurface of the walls are observed. Figure number 4. Radargram where the limit of the zone of fractures of the subsurface of the walls is observed. This extensive area of fractures intersects the base of the walls in which groundwater receptor zones have been determined in the form of small lagoons and also groundwater channels that flow in some cases according to the inclination limit of natural fractured zone of the terrain. If there is no control of this flow of groundwater under the walls, it will lead to the loss of soluble fractions of the upper layer of the soil and the loss of the bearing capacity of the wall foundations. It must be specified that it is not unique case in Sacsaywaman where such rupture zones are found. More similar examples at other levels are shown below. Photographs number 4 and 5 and 6. Surface analysis of the blocks. During the investigations of Sacsaywaman by specialists from GEO and Asociados SRL, considerable erosions of large number of stone blocks has been detected. To arrive at the answer to the reason for these processes, samples of the material that did not have any cultural or historical value have been extracted, carrying out spectral, physical, and chemical analysis in the various laboratories in Russia, so that can relieve us of the exact geological formation. These samples were provided by the employees of the complex. Goals. The proposed objectives were to show the similarity and the difference of the chemical composition and the structures of the samples taken from the walls of the archaeological zone of Sacsaywaman and the stone quarry, where the possible material for the construction of the fortress was extracted. This investigation is necessary to resolve two issues: the determination of the quarry from where the stone of the construction of Sacsaywaman was taken, clarification of the method of processing block polygons. Research methods and equipment. 1. Optical microscope. 2. X-ray, fluorescent analysis of chemical compositions. 3. X-rays, phase analysis of structures. Panoramic view of the third level of Sacsaywaman near the damaged wall, sample number 115. Place where the sample was taken, left image. Sample number 4 was taken from the quarry, where the probable material of the construction of Sacsaywaman, right image, was extracted. Panoramic view of the quarry, where sample number 4 was taken. Sample number 4 is a grey colored stone. Sample number 115 has a uniform, fine-grained structure. It can easily be scratched with a knife or a nail, leaving a strip of white on its surface. Sample number 4 is denser. It can hardly be scratched. It has a non-uniform structure with dots of light and dark tones. Both samples number 115 and number 4 dissolve easily in acetic acid and hydrochloric acid. The study of the petrographic thin sections taken from both samples revealed that the sample number 4 is an organic limestone formed by marine microorganisms. No doubt it's a natural stone. Here is a photo of sample number 4. It's limestone made up of organic material. Sample number 115 is uniformly constituted by calcite microcrystals of 1 to 10 microns. The identification of calcite is confirmed by in-phase X-ray analysis. We can also see small chains and lenses filled with thicker crystalline calcite. Photo of sample number 115, block of material from Sacsaywaman. X-ray fluorescent analysis show that the chemical composition of both samples is almost identical. On the column to the right, under sample number 115, we find the chemical compositions of the block from Sacsaywaman. In the column in the middle, named sample number 4, we find the chemical compositions of the sample taken from the quarry. Conclusion of the analysis. The chemical composition of the sample analyzed are the same, which would demonstrate that the material of the blocks in the sample from Sacsaywaman, number 115, and the sample extracted from the quarry, sample number 4, are both made of limestone. The process of making the block material is impossible to be a process of nature. Organic limestone with a hidden crystalline structure bound to water and at high temperature can be transcrystallized to a marble, but in this case the crystals will be large, because nature's processes go slowly, allowing the crystals to grow into their shape natural. The uniform structure of small crystals, as we can see in sample number 115, is possible to obtain only if the processes are very fast and each point of the system is provided with water and carbonate material. In general terms, according to the results of the analysis already carried out, the blocks of the Sacsaywaman walls can dissolve little by little in an acidic environment. The acidic environment is frequently seen in atmospheric precipitation in different countries that have heavy industry that involves acids such as mining amongst others. To verify this version, chemical analysis of atmospheric precipitation is required. If a small percentage of acids are found, modern methods will have to be applied to protect the archaeological complex of Sacsaywaman, such as creating a protective layer on the blocks. Additionally, an investigation was carried out in the circular area of the northern part of Sacsaywaman, since it interests us a lot from the archaeological point of view. To facilitate scanning, a rectangular area has been designated. In the image you can see how we mark the limits of the profiles with points 1 to 4. In total, 35 profiles of 50 meters each have been made. Distance between the profile is 1 meter. After the first data analysis, a 3D model of the investigated area could be created. The data obtained were sent to the Moscow Geophysical Institute, VNIISMI, for analysis. As a result, several quite peculiar underground objects have been identified. Between Mark II and IV, almost at the limit of the profiles, is a flat uplift near the surface, shown with the red arrow. This is a photo of a radargram with this object. The NIISMI specialist assures that this object is a tomb or a construction of the same structure. With 90% confidence, it can be said that the object was made by man. Likewise, in most of the terrain studied, a ditch was found with a depth of 2 meters and changing its length from 4 to 20 meters. In profile 8, at a considerable depth, a large rock in image 1 and a flat one in image 2 were found. According to the curves you can see that in the lower left corner the arena has a bottom in the shape of a cup. Conclusions. The studies carried out show a serious threat to the archaeological complex of Sacsaywaman. Under the walls of the main levels, breaks and cracks were found that create uncontrollable flow of groundwater, dislocation of fractions, and loss of bearing capacity of the foundations. It has been discovered that the capacity of the material that joins the blocks can dissolve in an acidic environment, constituting a serious danger as a consequence of rainfall that contains different components. In the sand zone, which is located in the northern part of Sacsaywaman, particular underground objects from an archaeological point of view were found: a tomb, a ditch, etc. The blocks of the bases of the first level were also scanned with small high-frequency antennas, discovering that they are low-density rocks covered with an artificial shell. This motivated us to send the samples for the corresponding chemical analysis. In this image is the materials that have been determined by the Institute of Geophysics and Tectonics of Russia. The result revealed to us that the blocks are not compact, but rather agglomerated, which show that the material used was collected in a quarry, subsequently ground, and used to make a mixture to create the molds of the blocks. Said material also erodes over time, due to water, acids, and other chemical elements from the rains. Another factor to consider is the seismic activity of Peru. The walls of Sacsaywaman needed to be solid and flexible at the same time. For this reason, the blocks were created in such a way that they achieved a greater area of friction between themselves. Each block was made based on the previous block, in order to have a strong union between them. Over time, the water dissolved the tangent surfaces between the blocks, decreasing the area of friction between them, thus threatening the stability of the walls. The Sacsaywaman archaeological complex presents two types of blocks, A and B. The type A blocks found in the first level are made of a number of rocks and a shell that cover them with analyzed material. This shell is the surface that is soluble in acidic environments. Type A blocks are made this way to receive the greatest amount of weight possible. Since the upper levels did not receive as much weight, their blocks were made entirely of the analyzed material. To be sure, the Type A blocks were scanned with georadar, and it has been shown that their interior is not homogeneous. As previously stated, Type A blocks receive the greatest amount of weight. Discovery of the Great Chincana. Taking advantage of the studies that GEO and Asociados SLR had been carrying out in the archaeological zone of Sacsaywaman, a scan was carried out in the area called Piedra Cansada with very favorable results. The interpretation of the radargrams has allowed us to find and delimit the tunnel, which is 2.5 meters deep, with a width of 1.5 meters and a height of 2 meters. That is, this technology has given a good result, but this is just the beginning. It is necessary to continue scanning the area to know exactly the direction, do excavations in the upper area of the fourth level, and carry out archaeological studies and see how you can protect the blocks and study the archaeological sand area. To prevent the destruction of the walls, it is necessary to analyze the subsoil and find all the rupture areas and verify their direction. Using this information, analyze the accumulation of surface waters and their flow direction according to the natural terrain. It is necessary to organize channels that intercept the waters and take them away from the walls. List of those responsible for field work: Leonid Krinitsky, marine geologist; Alexander Drostov, equipment operator; Andrei Veryanov, advisor to the VNIINSMI Institute; Ramon Sotomayor, metallurgical engineer; Luis Guevara, archaeologist, advisor to the INC of Cusco; Edith Quircuana Zavala, geologist, advisor to the INC of Cusco. Place: Arequipa, December 19, 2012. Now that I'm finished reading from the report, I will make a summary of the discoveries pointed out in the report. Discovery number 1. The building blocks of Sacsaywaman are artificial. The blocks used in the construction of Sacsaywaman were not naturally formed. Instead, they were artificially created using a unique process. The material for these blocks was sourced from a local limestone quarry. However, instead of using the extracted limestone directly, the builders crushed the limestone into powder. This powder was then mixed into a substance and molded into the polygonal shapes seen in the blocks at Sacsaywaman. The chemical analysis of the samples taken from the blocks at Sacsaywaman and the quarry showed almost identical compositions, confirming that the blocks were made from the limestone from the quarry. However, the structure of the limestone in the blocks was different from the natural limestone found in the quarry. The limestone in the blocks had a uniform structure of small crystals, which is only possible to obtain if the processes are very fast and each point of the system is provided with water and carbonate material. This suggests that the blocks were not naturally formed, but were artificially created. I would like to expand upon why the scientific analysis revealed that the blocks in Sacsaywaman are artificial, even though the blocks have the same chemical composition as the quarry. As I mentioned in the beginning of the video, one of the Russian scientists that performed the scientific tests was interviewed on the YouTube channel of Giacomo Langato. In this interview, the scientists explain in more detail how the structure of the samples from Sacsaywaman blocks differs from the structures of the samples from the limestone quarry. He explains that in the quarry, which is natural limestone, they can find shells and microorganisms that are whole, but in the samples from the Sacsaywaman blocks, the microorganisms are crushed into powder size, 1 to 10 microns. He compares the difference in structure of the quarry and the Sacsaywaman blocks to the difference in structure between grains and flour. They have the same chemical composition, but physically it has a different structure. Because grains are natural and flour somebody had to process. Somebody had to crush it into flour. It doesn't happen naturally. Here is an outtake from the interview where they talk about the analysis of the samples from the quarry and the blocks from Sacsaywaman. I will refer to the interviewer Giacomo Langato as Giacomo, and the Russian scientist Andrei Veryanov I will refer to as Andrei. Quote, Giacomo, here we have two screenshots. One is showing the natural conformation of the limestone. The other one is showing us the ones located in Sacsaywaman. So in other words, there is a pure material, no fossils, no microorganisms. What that means is that there was a process happening in between. What happened? Was it grinded? Was it added a new formula that conglomerate that into a kind of concrete? Andrei? Andrei, the Russian scientist. Yeah. First we take the samples from the quarry and from blocks from Sacsaywaman, just to compare. Then we see in the chemical analysis the same material chemically from the quarry and the blocks from Sacsaywaman, but the difference is the structure. The structure of the disseminated material. Because, like I said, limestone is a sedimentary material, and the natural limestone you can find shells and some microorganisms. But in the blocks, we see that it was crushed into very fine particles from 1 to 10 microns. Giacomo, so 1 to 10 microns? Like powder? Andrei, yes, actually it is like talc. Giacomo, okay, like crushed or grinded chalk, practically like wheat flour. Andrei, yes, and this means that this material was crushed by somebody, because it never happens in the nature. For example, grains and flour, the same chemical characteristics, but physically it has difference in structure. Because grain is nature and flour somebody had to process, somebody have to crush. Giacomo, right, that's the point, that's a big point. So someone, a team of people in ancient times, being Inca or pre-Incas, that is something completely different from the subject, was able to crush all these tons practically, all these kilograms, in order to create this concrete, adding a formula. And the formula, we don't know yet, right? It requires more research. Andrei, of course. That's the end of the outtake from the interview. So what implications does the discovery of artificially made blocks at Sacsaywaman have? The discovery has several significant implications. Number 1. Advanced technology or knowledge. The process of crushing limestone into a powder and using it to create a concrete-like material for the blocks indicates a level of technical sophistication that exceeds our traditional understanding of pre-Columbian societies in the region. This suggests that the civilization responsible for constructing Sacsaywaman possessed advanced technology or knowledge. Number 2. Reassessments of pre-Columbian societies. This discovery could prompt a reassessment of the capabilities and technical achievements of pre-Columbian societies. It challenges the traditional narrative and provides a new perspective on their architectural and engineering skills. Number 3. Questioning of attribution. While Sacsaywaman is traditionally attributed the Inca civilization, the advanced technology or knowledge suggested by this discovery could indicate that an older civilization may have been involved. This raises questions about the civilization responsible for its construction. Number 4. Need for further research. While this discovery prompts new questions and hypotheses, it doesn't provide definitive answers. Further research is needed to fully understand the techniques and processes used, as well as broader implications of these findings. In summary, the discovery of artificially created blocks at Sacsaywaman adds a new dimension to our understanding of the past, suggesting advanced capabilities of the builders, prompting a reassessment of pre-Columbian societies, and raising questions about the true attribution of this remarkable architectural site. However, further research is needed to draw firm conclusions. The second discovery from the scientific report reveals that there are two types of polygonal blocks used in the construction of Sacsaywaman. The scientists refer to them as Type A and Type B. Type A blocks. These blocks are found on the first level of Sacsaywaman. They are made of a number of rocks and are covered with a shell of analyzed material. This shell is soluble in acidic environment. The Type A blocks are designed to bear the greatest amount of weight possible. Georadar scans revealed that the interior of these blocks are not homogeneous, indicating that they are low-density rocks covered with an artificial shell. In some places, this quote-unquote cement was broken, revealing normal rocks inside. These blocks have empty spaces inside, suggesting they are not solid material. Type B blocks. These blocks are found on the upper level of Sacsaywaman complex. Since these levels do not bear as much weight as the first level, their blocks were made entirely of the analyzed material. These blocks are solid and look like plasticine. This discovery provides further insight into the advanced construction techniques used by the builders of Sacsaywaman. It shows that they used different types of blocks for different levels of the complex, depending on the amount of weight the blocks needed to bear. This suggests a high level of planning and understanding of the structural engineering principles. Furthermore, the use of an artificial shell on the Type A blocks indicates a sophisticated knowledge of materials and their properties. In summary, the builders of Sacsaywaman used two types of artificially created blocks in the construction of the complex. Type A blocks, used on the first level, are made of a number of rocks and are covered with an artificial shell. They have a non-homogeneous interior and are designed to bear a large amount of weight. Type B blocks, used in the upper levels, are solid and made entirely of the analyzed material. This discovery highlights the advanced construction techniques and sophisticated understanding of materials possessed by the builders of Sacsaywaman. The third discovery from the scientific report is about the underground structures found in the circular area in the northern part of Sacsaywaman. The scientists carried out an investigation in this area due to its archaeological significance. Using georadar scanning, the scientists identified several peculiar underground objects. One of these is a flat uplift near the surface in the Rotonda. The Moscow Geophysical Institute analyzed the data and confirmed with 90% confidence that this object is a tomb or a construction of the same structure, indicating that it was made by man. The scientific report revealed another significant discovery in the area called Piedra Cansada, located north of Sacsaywaman. Utilizing georadar scanning technology, the researchers from GEO and Asociados SLR were able to identify a tunnel or so-called chincana. The tunnel is 2.5 meters deep with a width of 1.5 meters and height of 2 meters. Further scanning is needed in order to find the direction of the tunnel. The presence of a tunnel adds to the architectural complexity of the Sacsaywaman site, suggesting that the builders not only constructed impressive structures above ground, but also engineered significant structures underground. Tunnels, or chincanas, have a special significance in Inca culture. They are often associated with sacred rituals or used as strategic passages. The discovery of a tunnel in this area could provide new insights into the cultural practices of the civilization that built Sacsaywaman. The discovery of this tunnel is just the beginning. It opens up a new area for exploration and study. Further scannings of the area could reveal more about the direction of the tunnel and possibly lead to the discovery of additional interconnected tunnels or structures.